All right, welcome to this lesson here where we're going to be taking a look at comparing and interpreting rates and starting off with what is a rate. And so that's where we're going to start off, and then we're going to work our way to how we calculate rates as well as how we can compare rates as well. So let's start off with the question, what is a rate? A rate is a comparison of two amounts that are measured in different units. We use rates all the time. Okay, we use it all the time. We see it all the time. And it's important that we understand how we can calculate them as well as how we can use them to solve certain things that we may have going on. So a couple different examples of a rate. We might be running 6.78 kilometers in 48 minutes. There you go. There's a rate. Okay, and that's going to be just a straightforward rate. Another one here, eating. I'm going to eat 150 calories in 4 cookies. Okay, so it's a comparison of units, calories and cookies. Another one here, typing. You might use this in a class, in keyboarding class, right? So we're typing 341 words in 8.3 minutes. Or something like costs, where where 53.6 liters is going to cost you $84.08. These are all rates. Okay, we also call these ratios. They are a comparison of two things. Now, each of these rates can also be made into a unit rate by dividing the numerator by the denominator. So we're going to simplify these down to make things a little bit easier to understand. Instead of saying that you ran 6.76 kilometers in 48 minutes, you could say you ran 0.14 kilometers per minute. Okay, there's a speed that we might have. Instead of saying that how many cookies you have, well, it's 37.5 calories per one cookie. Okay, that's another way to kind of think about it. Typing, 41.08 words per 1 minute. And that's how we can come up with that value. Sorry about that. And costs, we're looking at the cost per 1 liter, so $1.57 per liter. We're changing all these into what we call unit rates as we're making these rates per 1 unit. So the denominator is always going to be 1 unit, and that's it. Let's look at a couple of examples of how we can do this now. So here's the first example we're going to use. It's about Usain Bolt. You may remember him as an Olympic sprinter. He's since retired, I believe. But Usain Bolt broke the world record in the 100-meter dash in 2009, which has been a few years, running the distance in 9.58 seconds. What was his average speed during the race? Well, we can do some calculations. Our speed rates are always done in distance over time. Okay, so distance per time is exactly how we're going to do it. So to find his speed, we're going to take the distance he ran, 100 meters, and divide it by the time it took him to run, 9.58 seconds. Now, when we do this, okay, when we actually do the dividing to come up with our unit rate, we can say that we can divide and find that his speed was 10.44 meters per second. Okay, now that's pretty good. That's really fast, by the way, if you're running. But how fast is it really? We're much more used to writing things in kilometers per hour, at least here in Canada, or meters or miles per hour in the United States. Okay, so meters per second is not a very common unit for speed. So let's change this around a little bit and see how fast did Bolt run in kilometers per hour. Well, we need to change our units because the units we're given are meters and seconds, so we now need to change that to kilometers and hours. Well, 100 meters, we can change into kilometers because 1 kilometer is 1,000 meters. And the time we can change into hours. We can find that 1 hour is 3,600 seconds. Now, these are conversions that I would always give you. I would never expect that you know them without. But they are hopefully fairly common conversions when we need to make them. Let's do the conversion. We're looking to change 100 meters into kilometers. And so we do cross multiply and divide. 100 times 1 divided by 1,000 is going to give us a distance of 0.1 kilometers. So that's 100 meters, it's 0.1 kilometers. Then we're going to change his seconds into hours. It's going to be a very, very small portion of an hour because it's only in seconds. And so 9.58 seconds becomes 0.00266 hours. And we want to try to keep that as accurate as possible. And so try to keep a bunch of decimal places when we're doing that. Now, once we're at this point, we can just divide kilometers divided by hours, and it's going to give us a speed of 37.58 kilometers per hour, or maybe a little faster than I can bike. on the road. That was fast. Yeah, very fast. All right, so that's how we can come up with our rate, okay? Our unit rate being per 1 hour or per 1 second was the previous one we did. So here is another example. Now, I'm going to recommend that you try this example on your own. So pause the video at this point and then come back once you have the answer and we'll see how you did. The question that we have is, last week while grocery shopping, Lacey spent $4.19 on bananas. If she bought 5.3 pounds of bananas, what was the unit cost of the bananas? Every time we're dealing with money rates, we're always going to do dollars on top and then whatever else we have on the bottom. In this case, we're dealing with pounds, okay? Pounds of bananas. So our cost is going to be the number of dollars, okay? $4.19 divided by the number of pounds in this case here. So 5.3 pounds. All we got to do is divide, and we're going to get a unit cost of 79 cents per pound. Okay, so that's what we're going to do. All right, next one. We're talking about fuel economy. It's measured in how many liters of fuel is used for every 100 kilometers driven. That's the way we calculate our fuel economy here in Canada. Now, over one stretch of driving, we're told that John used 49.48 liters of gas and he drove 556 kilometers. What was his fuel efficiency? Give this one a shot, pause the video, and then come back once you have your answer. Let's go through the answer. Our fuel economy is going to be based on liters per 100 kilometers. This is the standard way of doing fuel economy, at least in metric currency. So liters per 100 kilometers, so we're going to take the number of liters, 49.48 liters, and we're going to divide it by the number of hundreds of kilometers that we have. So we're going to take our number of kilometers, divide by 100, and we get 5.56. And when we do that, we're going to get a fuel economy of 8.9 liters per 100 kilometers. All right, now you know that, but you may also have heard of miles per gallon. Well, imperial systems use that measurement to measure fuel economy. Can we do that given what we have? Sure we can. First thing that we know is that 1 gallon is equal to 3.79 liters, so we can convert the number of liters to gallons, and we know that 1 mile is equal to 1.62 kilometers, and therefore we can change the number of kilometers into miles and find miles per gallon. All right, we're going to change the number of liters to gallon, so we set up our ratios and solve that we have 13.07 gallons of fuel was used, and then we figure out how many miles we have, and we're going to figure out that that is 343.21 miles. And again, I try to keep a number of decimal places in order to get as accurate an answer as possible. Set this up in our ratio of miles per gallon, so that means miles on top, gallons on the bottom, and we're going to get 26.26 miles per gallon. So this is a way of describing our fuel efficiency in miles per gallon, which is an imperial system, compared to a metric system of liters per 100 kilometers. Okay, they're just two different ways of measuring our fuel economy. Let's take a look at another example, and this one has a few parts to it. So we have a distance time graph where you can kind of see how far someone has walked, maybe away from their home, or driven, or biked, or whatever it is, or Usain Bolt ran because it's pretty quick, compared to the amount of time that has passed. Now, this graph kind of goes up and then comes back down, and is showing kind of going away from home and then coming back towards home. And there's different pieces, so I've labeled them as A, B, C, and D. What I'd like you to try doing is to determine the speed of each interval A, B, C, and D, and figure out what the speeds were for each one. Now, just a reminder that speed rates are always done in distance over time, like miles per hour or kilometers per hour or meters per second. And so I'd like you to try to solve for these. I'm going to go through them once you've come back, and we'll see how you did for each section. Okay, let's go through each section and figure out what our speed was in each section. The first section, section A, the person starts at 0 kilometers, if we want to say away from home, and makes it all the way to 5 kilometers in a span of 20 minutes. So our speed is 5 kilometers divided by 20 minutes. Or we can change, and then because we're asked to find it in kilometers per hour, we're going to change the minutes to hours. So 20 minutes is the same as 0.33 hours. When we do the calculations, we're going to get a speed of 15 kilometers per hour. Would be a tough speed to run at for many people. Section B. Let's look at section B. Now, the difference. We're looking for the difference in the distance, and in fact, they aren't moving. They are always 5 kilometers away from home. So therefore, the speed that we're using is going to be 0 kilometers over the 20 minutes, or 0.33 of an hour if we change it to hours. And so our speed during that time is 0 kilometers per hour. C, we get back to moving. Okay, in this case, it's coming back, but because we're dealing with speed and speed is always a positive, we're not going to find a negative speed here. This would be a negative velocity, but we're looking at speed, so speed is always positive. So let's look for the change in y over the change in x, or the change in distance over the change in time. The distance that's changing, they're going from 5 kilometers away from home to 1.5 kilometers away from home. So that's going to be 3.5 kilometers. And the time is going from 40 to 70 minutes, which means that is 30 minutes. All right, we can change the time into hours. So that's 0.5 of an hour. And we're going to get a speed of 7 kilometers per hour. Now you'll notice that A was steeper than C, which means that A was faster than C, which is what we found, okay, by actually quite a bit. Now let's look at D. D is not as steep, it's much shallower, but we can still find the speed, it'll just be a little bit smaller. We have a change from 1.5 to 0 kilometers, which means that our distance is 1.5 kilometers. The time is 50 minutes. It goes all the way from 70 to 120. And so we can change that into hours, and that's 0.833 hours. Okay, we're just dividing the number of minutes by 60, and we get a speed of 1.8 kilometers per hour. So that's how we can find our rates. Okay, and we're again looking for unit rates, so we're always looking for it over 1. Okay, and that's going to be our goal each and every time. All right, let's look at how we can use these rates. Let's say that I filled up my truck, okay, with 84.2 liters of gas. When gas costs $1.41 per liter, there's our rate. What was the total cost of gas? Well, because we have per 1 liter, we're going to multiply the number of liters by the price. And when we do that, we get a total of $118.72. Okay, let's try another one. A top sirloin costs $13.99 per pound. If a certain pack costs a total of $8.74, how many ounces did the steak weigh? All right, pause the video here, try to solve this one, and then come back when you feel you have an answer. All right, let's try to find the answer here. First of all, what we're going to do is, because we're given the price, which is the top piece of our rate, we are going to divide by 13.99 to figure out how many pounds this thing is. When we do that, we're going to get that it's 0.625 pounds. All right, now we want to try to figure out how many ounces that is. Well, we take our number of pounds, we multiply it by 16 ounces per pound, which is our another rate, and we're going to find that it is a total of 10 ounces. I hope that you've learned something in this lesson. I hope that you're able to pull some of that back and that some of your answers were correct as you did the practice. Have a wonderful rest of the day, and thank you for watching.